Welcome to Embedded. I am Alicia White alongside Christopher White. We are entering our 10th bit with show 512. Our guest is Katherine Connell, aka Smalls, and we're going to talk about stretchable circuits, body-worn electronics, and, well, whatever we feel like.
Hi, Katherine. Welcome.
Thank you so much for having me. I'm really excited.
Do you prefer Katherine or Smalls in talking?
Let's do Katherine.
Cool. Could you tell us about yourself as if we met at downtime at the Maker Faire Bay Area?
Yeah. So I do a whole bunch of different stuff, from lights and stretchable electronics to animatronics. And basically, I just love to learn and make anything I can. I like to specifically do things that seem impossible or a little bit out of reach for what you would think that somebody at home making stuff in their loft would do. And so that's kind of what I like to do.
All right. But you do have a different career, day job, plan thing, not...
Oh, I do. I live like basically two lives. I don't know if you've ever seen the show Severance, but it's basically like I have an innie and an outie. So I'm like corporate by day and then just this like wild mad scientist by night.
That's a little disturbing, but okay.
Without the conspiracies, probably.
And the cult.
Right. That's where I was at.
Okay, so we want to do lightning round where we ask you short questions and we want short answers. Are you ready?
Yes.
Preferred fictional robot, Vicky or Baymax?
Baymax.
Stickers, shiny, puffy, flat, scented. What's your favorite?
Shiny.
Do you prefer your LEDs flashing, pulsing, or solid?
Solid.
Whew, that was a dangerous question.
Got to end the show if it was the wrong answer.
What kind of fake tattoos do you like best and why?
I actually only prefer my fake tattoos.
Do you like to complete one project or start a dozen?
Start a dozen.
If you could teach a college course, what would you want it to teach?
Watercolor painting.
Do you have a tip everyone should know?
Keep trying.
Okay, so now on to...
That was the lightningest of lightning rounds we've done.
It was short, yes.
You said make it short.
Yes.
Most people don't listen to us.
We have a quick break before we jump back in. If you're interested in how 3D printing is changing design engineering, Mouser Electronics has some great resources to check out. Their Empowering Innovation Together platform is taking a deep dive into additive manufacturing. That's 3D printing. They're covering smarter production, faster prototyping, and breakthrough materials that move ideas beyond prototypes into real-world products. You'll find podcasts, expert articles, and videos to keep you informed and inspired. Sound like your thing? Head over to mouser.com/empowering-innovation and explore their latest content. Now let's get back to the show. You grew up a maker or a child of makers. How did you come into the whole maker space?
Sure. So some of my earliest memories, and I've talked about this a lot in various places, is being in my garage in the 80s in San Jose, California, the heart of Silicon Valley, helping my dad box graphic cards to go sell at Fry's Electronics. I'm like on a step stool in this garage, putting things into foam and into boxes. And they were graphic cards that my dad had designed and that we were going to go and sell there because that's how Fry's Electronics used to work. And then obviously my mom also had an influence. She was more of a traditional maker. She likes to cook. She likes to do traditional art, but she also saw my passion for the stuff that my dad was doing. And we would get those cute little at-home robot kits that you used to be able to get, like the ones where it had like a robot that had wheels and you couldn't control it, but it would run into a wall and it would hit a sensor and then go off in another direction. We used to do that type of stuff all the time. So from a very early age, I got to do a lot of I think things that kids, of that time didn't really get to. We were early adopters of technology. We had computers in the house super early on. And also they were big sci-fi nuts. So we were watching The Next Generation. I was a little sad you didn't ask me if Data was my preferred robot. I know he's an android. It still counts. And Red Dwarf and all sorts of other kinds of influence was in my life at a really early age.
I mean, going back to the robots, I was kind of surprised that Vicky didn't get a nod at least.
I mean, I get it, but also that show, even though I took the moniker of The Small Wonder because it's fun, that show was objectively terrible.
Wikipedia does say it's the worst sitcom of all time. And, it's true on Wikipedia.
It's awful. It's awful.
I don't remember what. So I used to watch that show, but I think it was only because it was on before something else. And I caught the last, 5 minutes of it every time.
Yeah, it's quite awful. And the only reason why I took that moniker is because of that story of helping my dad do electronics in the garage. My parents used to joke that I was a robot made out of the greatest and latest technology of the early 80s, which also explains why I'm slowly breaking down over time. But people say it's aging. I think it's just, a planned obsolescence at this point.
Do you have an RS-232 under your left armpit?
I might. I just might.
So not to belabor this too long, but I'm curious a little bit about the graphics cards because were these for PCs or Apple IIs or?
God, I don't even remember because I was like 5.
Yeah. That would probably be the time when Heathkit was a store you could actually go to, and they had all the robot kits and radio stuff.
And Radio Shack was Radio Shack.
Yeah.
Oh yeah, loved Radio Shack. We used to go all the time.
But your degree is in graphic design?
It's a true story. I don't actually have a full-fledged degree. I went to school and never finished. And I studied both communications and graphic design at the time.
And you said when I asked what kind of fake tattoos you like best, you said your own. Can you describe those for people who haven't seen them?
Sure. I call them sprite lights. They are essentially a sticker that sticks on your body, and it has LEDs underneath it. And so it takes traditional art and then lights it up. And makes it very beautiful and bright. And you would think that would be bulky, but they're actually less than 2 millimeters thick. So they are extremely comfortable to wear, and they look just like they're on you as if they're painted.
And they have a battery.
They do.
Tell me, is it ultra thin, flexible? Tell me more about the batteries.
Yep. So the batteries are made by Zenergy. They are a brand that I think is essentially UK based, but obviously have manufacturing capabilities in, I believe, China. And they are about 0.7 millimeters thick of that 2 millimeters I was talking about. And they use screen printed technology. So the same type of methodology you would use to screen print a t-shirt is what they use, but with battery chemicals. They're single use, but the exchange is that they're extremely safe. So you have something like a lithium ion battery, but those have potential to get really hot. And when I was planning something to wear against your skin, I really didn't want anything exploding, or getting too warm or catching fire when you're wearing it. And so I exchanged the, rechargeable capabilities of something, that would last longer with a single use battery that was extremely safe. You could literally cut it in half while you were wearing it and nothing would happen to you. There's no chemicals that leak out. There are no, there is nothing that can happen with those.
I mean, that's kind of amazing.
Yes.
And then you also had, it doesn't feel like you put a sticker on. It doesn't feel like it is more like a fake tattoo than a sticker, right? There's some flexibility and it's on your skin.
Yeah, it doesn't feel really stiff. And part of that is thinking about the design of it. One, you don't want it too big because if it's too big, it could feel like a sticker and tug against your skin and pull in weird ways. The second part is you don't want sharp edges, like a hard square wouldn't do as great as a circle or even a rounded rectangle. And that helps conform to your body and go with natural movements as well. And also partially because they are so thin and so flexible, that also really contributes to it feeling more natural on your body.
And then what are so we have 0.7 of the 2 millimeters is battery, and some small amount is sticky stuff. Mm-hmm. What else is in your stack up?
Yeah. So you start with the bottom layer, which is the sticky stuff, which is a medical grade, pressure sensitive silicone adhesive base. And so it's hypoallergenic, and really comfortable. Then you go into the battery sits right on top of that. On top of that is a flexible PCB board, super, super thin. And then on top of that is the sticker, and that's it.
So flexible. For some reason, I thought this was stretchable.
So I went stretchable for a really long time and then determined you don't actually need to be stretchable for this. But I did do like an excessive amount of research and work into stretchable electronics only to end up figuring out that I was over-engineering. But I did learn a lot of really cool stuff. And I think stretchable electronics are going to have an application in the future. I think if you needed to go over a larger surface area than my light up stickers, temporary tattoos do, you are going to need to start going into stretchable. So if I, for example, was to do a full back artwork of this, you would probably have to move into the stretchable area of things as opposed to just flexible.
So let's talk about what those are. Like, you get a flexible circuit from a vendor, and what do you feel?
Tell me a little bit more about what you're asking.
Fair. Okay, so I've had stretchable circuits. I've had flexible circuits, and they often feel a lot like ZIF connector cables, because that's what they are. And it's a plastic membrane. There's some metal on it, and lately there's like plastic on both sides so that the metal doesn't touch itself. Which, in the beginning, that was not a thing. You just had to be careful. Sorry, where was I? Oh, but it feels like you took a credit card. You took a piece of plastic, and you just made it super thin. And so it's like transparencies is kind of what it feels like to me.
Acetate,
yeah. But it's that weight and flexibility, and that sharpness of edge, actually.
Yeah, that's true. So when I first started, I was basically taking acetate sheets and making my own flexible prototypes at home. We can talk a little bit more about this later if you'd like, but the cost of small batch manufacturing of getting, PCBs, of flexible PCBs from somewhere like PCBWay or what is that other one, JLC, it can be really expensive to do, even to just try to like small batch prototype. And so I had to figure out how to do my own flexible circuits at home. So I did actually take essentially transparency sheets, some of the higher temperature resistant ones, and I would cut out copper traces on my silhouette cutter, like one of those little paper cutters. By the way, that dulls your blades really quickly. I would eat through them extremely quickly because you're even if it's thin copper metal, it's still metal, cutting metal, which makes it dull so fast. But I would take that copper tape, which was adhesive on one side, and be able to stick it to the transparency sheet and then use the silhouette cutter again in order to cut out the shapes and everything like that. The key to getting around those sharp edges is making sure that you have room around your circuit. So whatever you're sandwiching it between, in the beginning, I was doing silicone artwork and then having a substrate on the back that possibly will give me cancer in my old age. It was from China and it was wild. But it was the same thing that you use in adhesive bras. And I would coat the back with that, and let it cure. And the key to getting around those sharp edges was having it sandwiched around something that didn't have sharp edges.
So I have a Cricut, which I think is similar to a silhouette. Have you seen both?
Yeah, I've seen both. I really liked the silhouette because of the software that you could use in order to create your artwork to cut it out. I had tried to use the Cricut environment before and found it a little too proprietary and kind of restrictive. Yeah.
My Cricut, I had to replace the rubber wheels, and now it's very loud, and I'm trying to decide whether I'm going to try to fix that or get something new. And so you said silhouette, and I was like, well, I should ask her.
Yeah, the silhouettes are great. I think that they might be falling a little bit to the wayside. I've stopped seeing as much as of their products out in the wild, like at a hobby store, than I have the Cricut stuff. That said, they still have all of their stuff online. So as long as you don't mind doing online ordering, I think they're still an incredibly viable option.
Cool. Sorry, everybody. I was more interested in origami than the podcast for a moment. Which actually, when you do cut out your circuits, do you put spaces in between? Do you have little cuts so that the acetate can move more freely? I'm thinking about kirigami, but I don't know if that's a term everybody knows.
It wasn't really particular about how I did my spacing or anything like that. The silhouette has a really cool function where it has a specific mat with different markers on it. And so you take a picture of it, and then you load it onto your computer, and you can trace out where you want to cut things. And then you load it into the machine, and it just cuts according to those markers that it has and what you've done on the computer. And so it was really easy because you have to go back and forth in this process, a lot of cutting out the copper traces and then getting it onto the acetate and then creating your outline for it and making sure it aligns with your stickers. And so there's a lot of like loading and unloading and trying to figure out where to place things. And because it had that picture mat with the markers, it became really easy, and you didn't really have to fuss that much with your layout.
Is this mostly vector programs that you're using, or?
Yes.
Okay. Yeah. So that's how you do the drawing is through the vector programs, and then the vector programs get translated into G code, and then the silhouette is basically a CNC, but with small knives and pens and other things.
Yep. And that's correct for the acetate layer, the traces for the copper, but the artwork was never vector. I find vector to be sometimes constricting for what I would like to artistically do.
Well, especially if you're doing watercolor style things. I mean, that's not a vector thing. What do you use for creating your art?
So a lot of it is traditional methodologies. And then sometimes I'll do digital coloring. It kind of depends on what I'm going for. But a lot of it starts with sketching by hand, sometimes translating that over to a tablet. The one that was in my actual produced Sprite Light that people could go buy out in the world for a little bit was all traditional artwork. It was watercolor with pens.
That I got some, and they look kind of like a compass rose to me.
Yep.
Was that was intentional?
Yes, it absolutely was. So I was looking for inspiration for our work, and I wanted to do something that was meaningful for me. And my sister happens to have a compass tattoo. It doesn't look like the one that you have, but my sister and I have gotten really close over, I think our adulthood mostly. And I wanted to do something that was a tribute to somebody who has been a huge inspiration and love of my life. And so she has a compass tattoo, and I use that as a starting point for inspiration to create something.
But when I was looking around on the internet, I saw some with butterflies, and they were very pretty. When can I have some of those?
Everyone loves the butterflies. Those are early prototypes, and they were
some nice, some subtle but cute series of sakura flower, cherry blossom flowers.
Yep. Yeah. The tricky part of where we ended up with the needing to be able to do these in bulk is that sometimes you have to get a little less elegant in your design, and the butterflies and the some of the more subtle designs that you really liked require a lot of transparent space. And that doesn't necessarily translate to what you're able to get manufactured for the PCBs. So having transparent PCBs, we're still a little bit away from being able to do that in mass production at a cost that I could afford. And so even though I was able to get flexible PCBs produced, in bulk, they had to have a solid background, which makes them a little more prohibitive for what I'm able to do.
What color is the background?
The background on the ones that you have for the compass are actually white.
Okay. Well, my skin's so pale I wouldn't notice.
Yeah. And you also have to keep in mind batteries. So those batteries...
Right. The battery wouldn't be clear.
The battery would not be clear, which is also why it becomes different when you go to produce them. Some of the early ones you saw, I hadn't figured out a true battery solution yet. I was hiding coin cells underneath, and in the pictures they look good. In real life, they're much more bulky, and so these energy batteries can only get so small because they're so thin. They need to be bigger, and also you want to have a design that can be reused multiple times. So because there's ones that are like the circular size now, I could do basically any circular design and have those batteries be used for it. But if I was to do a butterfly, I would need them to design essentially a butterfly shaped battery. And okay, that's the only time I get to use that, because you need to use every centimeter, every millimeter of space you can to get battery life out of it.
Yeah. So you are powering LEDs, and LEDs of that size are relatively cheap to power as far as energy budgets go. How did you figure out how many LEDs per square centimeter you could have?
A lot of trial and error. They do consume a small amount of energy. The hard part is that they require usually at least 3 volts in order to get a reasonable brightness for them. And so it was less about battery life and more about, can I get these bright enough that I feel like this is an impactful thing that you can wear, because you're not just wearing them at night, you're wearing them sometimes in the day to go to something that you're going to, or indoors where there's still lighting. And so that was actually the bigger challenge. I tried doing the online calculations for how much battery do I need for X, but really it came down to just running a lot of battery tests when I got in the units.
And how do you do resistors at this scale? I mean, I'm okay, so maybe you should consider making the LEDs not as bright by adding a larger resistor, and then it would last longer, but that doesn't quite work. And how do you... 2 millimeters. And now, as you mentioned with the stack up, you must only have about 1 millimeter for the board, if that.
Mm-hmm.
How...
That's correct.
I know LEDs come in very small sizes, but...
They're extremely small. And the resistors come in equally small package sizes as well. So I want to say, it's been a while since I looked at it, but I think I ended up with a 0603, which is, if you are to look it up online and be what size are LEDs? And you look at they're little grains of dirt. They're oh, don't sneeze or cough while you're using these, because they're just you will never find them ever again. Also, you might inhale one, at that size. You never know. So just, you got to be careful.
It's a whole other product.
Do not snort the resistors.
Yeah, do not snort the resistors or the LEDs.
What's assembly like? Are you putting these together by hand? This is, like you say, very, very small components, very flat surface, and very, a stack of things. How are these put together?
Yeah, for prototyping, back when I was still making my own boards at home, it was with a hot plate that I bought from Walmart. And a lot of praying and very carefully watching when the solder would get shiny, and then turning it off and pulling them off immediately and praying that I didn't ruin anything.
Wait, this was on the acetate?
Yes. Yeah.
Okay, there's so many things that can go wrong here, right? How many?
Yeah, you can melt your plastic. Nothing ever lit on fire.
You're thinking of celluloid.
Yeah,
I am thinking of celluloid. Right. Okay.
Yeah, it couldn't catch on fire, but it could warp and melt if you were not careful in
Like,
watching it.
become an unintentional shrinky dink.
Yeah.
Yeah. It was a wild balance between getting the solder to melt, not melting the adhesive that was holding on the copper, like not getting that too hot, and also just like getting your solder to actually stick your components to it. But it was possible after a little trial and error to find the right balance of it. So it wasn't, in the grand scheme of things, too hard. But when I went to go do the Compass Sprite Lights designs that were funded by the Kickstarter, I was going to make hundreds of these, and there was no way I was going to be doing that. And so what I was able to do is have PCB assembly actually done for me on the extremely thin, flexible circuits that I designed from PCBWay. And the key to that was panelizing my designs. Yeah. It wasn't just like one by one. It was, I think there was 9 of them on a panel. And so they were able to do sheets of them. It did mean when I got them back, I had to punch them out of the panels. I had to pull all of them out. And then the assembly of the Sprite Lights themselves, of the medical tape layer, battery, circuit board, and sticker, that was done by hand while I think I watched the entirety of the Lord of the Rings, like every single last one of them, and then I also watched Harry Potter. And so it was
a long build.
Yeah, it was a long build to do. I think it was like around 500 units that I was done. And I had 3D printed basically an assembly process. So they were templates of like, line up this up here, put this one here, put that one there. And it was like stacking of little templates so that I could get everything in exactly the right place every single time. Because if you look at the compass design, the LEDs are very purposely on some of the points of the compass.
Okay, so I understand why you made these, because they're so cool. And I understand why you would want to make them small. And your home process sounds difficult, but possible. What made you decide you wanted to sell these? I mean, building a small business like that, Kickstarters are not easy. Why did you... Why?
So I'm one of those people, as you heard in the lightning round, who would prefer to start a dozen projects versus completing one project. Sprite Lights was my experiment into what if I didn't stop. When I got into doing this project, it was like one of those bugs that you just couldn't get rid of. I would wake up thinking about it. I'd be like, how do I advance it to the next stage? And it was a problem that I really wanted to solve. And somewhere around the 6-month mark of having just started into this, I believe it was in 2017 or 2018, starting to do prototypes and really exploring this idea, I thought to myself, what if this is the one that I take as far as I think I can possibly take? And just see where it goes, see what I am capable of. And so even when I would hit roadblocks of not knowing the battery solution, for example, the batteries took, I think, 4 or 5 years for technology to catch up to what I actually needed to be done. Even when I hit those roadblocks, I would go into a different part of the problem I had to solve and be like, okay, well, I'll come back to that and we'll give it a little time and see what happens. And so why sell them? Because, well, I hadn't done that yet with it. And I also got extremely lucky. Well, maybe a little bit of luck and maybe a little bit of really hard work over the years, but I won a contest with Hackster.io for Sprite Lights, and part of the rewards was launching a Kickstarter and having support and help in order to do that. And so since I won that contest, I was like, well, what happens if I don't stop? Let's try it. Let's see what happens.
And yet you're going to do it again?
Not currently. I am unfortunately a little bit on a hiatus with it. As we know, the world has become an extremely interesting place over the last few years here. And costs have become prohibited due to things like tariffs. So small batch electronics, like doing even 500 of these, still has a very small profit margin. And that profit margin has been eaten up through shipping, through these tariffs, through a lot of things. So it would cost me money, or I would have to raise the price to something that I don't feel would be accessible. And I'd rather just not do them than have them be such a like behind such a barrier to be a luxury product. I'd rather wait and think about it a while and then maybe pick it up at a later time where it makes a little more sense to do so.
Have you gotten stopped while wearing Sprite electronics in the wild?
Oh, yeah, all the time. I did a lot of adhesive tests both for the Kickstarter and then also in the prototype days, like when I was trying to hide batteries in various places. And so I wanted to make sure that these would stay on if I went out for the night, if I went dancing, if I, got drunk at a bar, and was not the most careful with like bumping into stuff, all sorts of scenarios. And people were like, what in the world is that? And where do I get one? So they have a huge appeal out because they're bright and they're shiny and they light up, and nobody's ever seen something like that before.
You worked with the sticker manufacturer, but that was just the top layer, right? You mentioned building it at home. I guess I was kind of hoping you could tell me that there were sticker manufacturers that had learned enough from you that they were going to do it on their own.
No. So Make Stickers was a really, really great partner for the Kickstarter. I actually approached them on my own because I had been using them for my prototypes and found them to be just like a really good quality sticker. They had a lot of finishes that I liked, and they were thin and they were durable. And so I approached them when I started the Kickstarter and said, hey, I will brand the crap out of you. Would you like to be a sponsor? And they got back to me within a day, and they're like, oh my God, this is amazing. Absolutely. We would love to do this. And so they were a great partner. But no, unfortunately, no sticker manufacturer that I've seen have figured out how to make light up stickers yet.
If any sticker manufacturers are listening to this, please make light up stickers. You mentioned that you went down the whole stretchable circuit path before you realized that it wasn't necessary. If you were going to do this again, would you reconsider that?
No, because that was such a fun journey to go on. It was extremely frustrating at times, but also just, it felt like I was in cutting edge electronics in my, house, which is such a neat feeling. And also, I learned just so much about electronics in general by trying to do that, about the limitations of technology today, that I think really helped refine my future processes, even when I decided flexible was good enough instead of stretchable. And also I got to smelt metal in my driveway during COVID and cackle wildly while my neighbors were worried I was going to burn the entire, neighborhood down. It was super, super fun.
Okay, we said that flexible circuits, we kind of made the analogy to acetate or transparency material, the plasticky stuff that wobbles. I'm holding my hand and I'm doing the
clear sheets of plastic.
But if we're talking about stretchable circuits, we're still talking about clear sheets of plastic, but they feel totally different.
Right,
but they're softer than even
trying to describe
cellophane or saran wrap. They're
I like to think about it as those stretchy hands that you used to throw against the wall, and it would
gel
spread out and
thing.
stick, and or the little things that you would throw against the wall, and then they would just roll down on their own because they're sticky and they would splat against it. That is way closer to what I was doing when I was doing stretchable circuits.
But not slimy at all, just sticky.
Yes, that's correct.
Okay, so smelting metal. Is this what is the one that melts the spoon? Gallium?
Gallistan.
Gallistan? Gallistan's the brand name, right? It's a combination.
It might be. Okay, you might be right.
Gallium is the metal, the element that is
has a low melting point.
Has an
so you can melt it in your hand.
Low melting point. And if you ever see somebody have a spoon and they're like, oh, clink, clink, it's a real spoon. And then you put it in their coffee and it disappears, that's probably because it melted.
And don't drink that coffee.
It's heavy enough you can drink a little bit.
Great.
I mean, it's a traditional magic trick.
It's non-toxic, so you won't die, but I don't recommend it.
Yeah, we don't recommend this. Okay, so Gallistan is a mix of that and a couple other things, indium and tin. You can eat tin, but I don't know about indium. So let's just not eat this either, okay? In fact, don't eat anything mentioned on this podcast. Okay. Was this what you were smelting? Because that
Yes.
seems kind of easy.
Yes, that's absolutely what I was smelting.
Okay. And why? I mean...
I mean, that's a great question. It was really expensive to buy, like already pre-made, like to get the really good quality stuff. You can buy like the super cheap, like magic trick stuff from, I think, Amazon or something, but, its qualities weren't super great for trying to sandwich it between silicone and create circuits. There was something about it that just was even more difficult than normal. And so I managed to get some of the high quality stuff, and I spent a lot of money on it to do it. And I was like, that's not practical, but it was significantly cheaper just to buy the 3 different metals I needed and get a little camp stove going out in the driveway and make my own.
So the combination melts at minus 19 Celsius or minus 2 Fahrenheit. So
Wait,
it does say minus.
I don't think that's right.
That doesn't sound right.
That doesn't. Wikipedia, what are you doing to me? Okay.
I don't remember the exact temperature, but it was achievable with a camp stove.
The next one says 11C and 52F. I don't know. Wikipedia is wrong. Somebody go fix it for me, please. Anyway, the combination of this is melts. I want to say boiling water temperature. What you said, camp stove.
Yeah. And so basically it was, a lot of what I do isn't extremely scientific. It's a lot of like watching it and saying, that looks pretty right. And so I did a little bit of that in my driveway. I believe I had like a thermometer that was in there and reading it and everything. And I do not remember the exact temperature, but when it got around to that, I pulled it off. But it was also a little bit of looking at it and seeing, does that look like combined melted metal? Okay, that looks good. Take it off the stove.
So that's what's replacing your previously silhouette cut it out copper tape.
It was for a little bit. It was, as it turns out, it is extremely hard to get anything to stay in place on a silicone base. And I was using a silicone base for my artwork. I was using it as like my adhesive. It was a body safe, material that was the kind of the heart and soul of Sprite Lights for a really long time before I moved on to the actual sticker artwork. And to get anything to wet, to stick to silicone is insane. I actually end up stealing this technique from, I'm going to butcher some names for you, Stephen Nigels, Raf Ramakers, Chris Luton, and Wim Defreme. They did a scientific paper on this for silicone devices, a scalable DIY approach for fabricating self-contained multi-layered soft circuits using microfluidics, which is a really fancy way of saying that they put this low melting point metal and sandwiched it between layers of silicone and used, standard traditional electronics, components, embedded in that as well to make really cool stretchable circuits. And they had significantly better equipment than I did, since they had an actual lab. I believe they had at least a small amount of funding for this. They were in school while they were doing this. And so I kind of stole their technique for doing it, but they had much more consistent results due to their equipment than I did. And so this was a rabbit hole that I went down for a little while, but it turns out I just didn't have the technology at home, which is a very common, barrier for homemakers, in order to consistently do it.
Okay, so silicone, not silicon, but with an E at the end.
Yep.
This is the stuff that goes on like Silpats and other baking mats that
high temperature
are high temperature and very, very non-sticky.
Mm-hmm. That's correct.
And so you're trying to stick things to materials that are well known for being non-sticky.
That's correct. Because I like to be difficult.
Yes, who doesn't? And somehow this metal might do that if you have the right equipment.
Mm-hmm. That's correct. And so what it does is it basically creates a channel of liquid inside, because the one thing that silicone really loves to stick to is itself.
Yes.
And so if you have something in between it, like a channel of liquid metal, very, very thin, keep in mind it's like a painted line almost, and then you surround it by, silicone on any other side of it, it becomes a little place where it just lives, and you can stretch it and it's self-healing. The metal will, because it's liquid at room temperature, or warmer, it just, it just stays there and it flows with it. And that's what allows it to stretch. And you couldn't do this with any metal because you need it to be a liquid form. And you could beg the question of, could you use any other type of conductive, liquid potentially, but what was really interesting about Gallistan is it essentially wets the material. If you do it just right, it wets the material and stays in place. So you don't have to pre-make a channel. Like you don't have to like pump it in with a syringe or anything like that. You can literally paint it on using a template if you manage to get the conditions just right, and then it'll stay in place while you put the other layer of silicone on top to trap it.
But what if you did make a channel? What if I went up and took the Silpat that has gotten stained and put it into my Cricut and made a little cut, and then I could put the Gallistan into the little cut, and then it would live in that channel, and then I would have to put another Silpat on top so that it would stay there.
You can do that. Gallistan is not like water consistency. So trying to pipe it into something, you get a lot of beating and it's a little unpredictable for how it comes out. You could try to scrape it into it. But while Gallistan won't wet something very well, like it won't wet the silicone very well, it will stain the crap out of it. So it's not conductive, but now it's ugly. So I did try that technique a couple of times. I would like say 3D print a mold that had like these little tiny channels, like raised out of it. And I would put the silicone over it and then I'd peel it off and it was great. And I had my channels, but trying to get the Gallistan in there was a nightmare.
Huh. Because that was the other thing that silicone can do really well is it's very, very easy to mold.
Yes.
And so it seems like you should be able to do exactly what you tried, and now you're telling me it doesn't work. And I believe you. I just wish it did. Did you try heating it up in that? Does it get wetter with heat? The metal?
Not really. Once it's in liquid form, it's in liquid form. If you had bigger channels, it would probably work just fine. But keep in mind that my nickname is Smalls. I was trying to make it very small. And so we were trying to do, traditional traces with it that were, at most like a millimeter thick or wide. And so if you were to do, I don't know, like 3 millimeters even, you could probably get away with it. So if you're looking for bigger channels, but then it gets kind of expensive because even making my Gallistan at home was not super cost conductive.
And the Gallistan is often considered a replacement for mercury in some things, like I guess it's more the gallium is replacement for mercury in thermometers. And it does, you said it beads. So it's like mercury in that it will flow if there's enough of it, but it will bead if you only have a little bit. And then it makes the little round balls and they go all over. And then you're like, oh my God, I just mercury poisoned the whole school. Wait, no.
Yes, that's correct. Without the poisoning part for Gallistan.
But with Gallistan, apparently it leaves a mark. So everybody knows you've done this.
Oh yeah, and it's impossible to clean up too. Once it doesn't absorb, it doesn't dilute. Like you can't spray cleaner on it and like wipe it off the table. As I was experimenting with it, I would say a month or two ago, where I was trying to pipe it into very thin silicone tubing to make really stretchable wires, which works. It's really cool, and it definitely works. But I spilled a little bit on my table, and like I've wiped it and like gotten it to the edge and gotten it off, but there is still like certain gray marks on my desk that I always find here and there, and then like you try to clean it and you think you've gotten it. Oh, it's a nightmare. It is so hard to clean. So I recommend gloves, and I recommend like some kind of covering over your table that you want to throw away when you're done. Like it's going to be there forever.
And it's conductive, but not magnetic.
Mm-hmm.
So yeah, there's no easy way to fix that.
No.
All right then. But people who are not necessarily doing this on their kitchen table, again, don't eat anything in the podcast, can make these. I've seen videos of these stretchable circuits, and they deform over 100%, and then they snap right back, which I guess is what silicone does.
Mm-hmm.
I can see why you don't need this for tattoos, and yet there has to be a use for it. I mean, other than the obvious medical uses, I mean, that's cool, but let's do something a lot more fun than that.
I think you could. I've thought about a lot about this. Like, what is the application for this? And I think anything that is conforming that needs the ability to adapt and move over time. So medical devices, I think this kind of technology could be really important for it if you were doing like large swaths of your body for monitoring or anything like that. I also think that there's potentially a fashion element to this. Gloves, socks, anything that like you have to like pull on and it has to stretch as you wear it. I think that there could be a really interesting application there.
Ooh, what if
Yeah.
instead of the piano key lighting up, your finger lit up with the one that was supposed to go down?
Exactly. So there's so much really cool stuff. Like anything where you just need complete freedom from wires, I think that this could be it.
I always need complete freedom for wires. The medical applications I saw when I was looking at it were things like putting it on a joint so that you can monitor if the joint is moving correctly or if the joint has moved too far or is otherwise stressed. For people doing physical therapy or recovery from injury. Which, I mean, given that they're made to wear for weeks on end, it's pretty darn cool. But then how do you take this Galveston circuit and this silicon stretchy stuff that it's put upon, that is the PCB, and then attach it to, I don't know, anything else?
So that's where silicone-based adhesive comes in. So what we've learned is that nothing likes to stick to silicone except for silicone. It loves to stick to itself. And so there is a huge array of different silicone-based adhesives out there, both for commercial uses, but also medical uses. And those use what are generally called pressure based or pressure sensitive silicone adhesives. And so they're sticky, but also something about like the pressing of them helps it adhere. And they're made to stick to skin specifically. They're sweat resistant, they're hyperallergenic, they're all of those things that you would want for body application. They can be a little hard to get your hands on as an at-home maker. But if you were to, have large-scale funding for something like this, like some of the applications that you saw, they're definitely out there and available.
No. So one of the hard things with flex circuits, if you're attaching them to traditional electronics or traditional batteries, is that there has to be that connector that's a pain. It's really a pain in my life, is this ZIF connector. So many problems. And it's hard to solder the flex circuit onto a traditional board because the flex circuit tends to melt. Have you looked at how to do the stretchable circuits into a traditional circuit?
No, I haven't really explored that avenue.
Okay. If you have and you're listening, please feel free to send me an email. I don't have to share it with anyone. I'm just curious. Okay, so stretchable circuits, obvious skin-based computing application, also soft robotics, which is another place that silicone comes in a lot. Have you looked at any of that? Because, I mean, that could be your next Kickstarter. I desperately need a small light-up worm wandering around my living room.
So I had gotten into companion bots a little bit ago.
Yes. You did a fox, right?
I did do a fox, and the entire purpose of that fox was to combine what felt like traditional puppeteering, like mechanics, like the animatronics that you might find at a Chuck E. Cheese, pizza show back in the 80s with, some more newer technology. But I really wanted that, a little uncanny valley, slightly unsettling feeling to it. That was where I was going at the time. And I learned a lot about robotics, animatronics, et cetera, making natural movements or unnatural movements, if you will. And I've thought a lot in some of my I can't sleep right now, kind of evenings that I get about creating a completely flexible, squishy kind of companion bot, combining what I've learned about the stretchable circuits. It's part of why I was working on stretchable wiring with the Gallistan a couple of months ago, because I was thinking about how you could embed that into a silicone body and then have everything just be really stretchy. Like instead of, you pet a companion bot and reacts to, what if you squeezed a companion bot and it like reacted to you? That would be so weird and kind of cool.
Sorry. My brain just wandered off into, what if it was a lightning bug and when you hugged it, its butt not only lit up, but also because you hugged it, you moved the space and it ballooned out a little bit too. That would be so cool.
Sure.
Yeah. Okay. That would.
What if it was an octopus and like when you patted its head or squished it a little bit, like all its tentacles flailed around and they were squiggly, like there's so much you could do.
Well, and some of it you can do mechanically and then just augment it with the electronics.
Mm-hmm.
Like the lightning bug, if you squish it, then that balloon action doesn't have to come from the electronics. It can come from the mechanical air. And the same with the octopus. If you touch its head hard enough, it can put air into the tentacles, and then the electronics can measure that and utilize the change in elasticity. And oh my God, I am not going to spend my life on this right now. I have so many other things going on.
One project or 12 projects? Which one are we doing?
I mean, this is episode 512, so I feel like we have gotten one project down, and now we can move on to the other 11. That's so not true. I usually have at least 11 going on at any one time. Okay, so one of the questions we got from a listener was gallium in silicon tubes for flexible electronics. And there was the question of the stretchiness squeezing the gallium, which changes the resistance. Do you look at that, or as you said, you make it work and don't worry about the rest of it?
I generally make it work and don't worry about the rest of it. However, when I was working recently on the stretchable wires, I was looking at resistance because resistance can be a trigger to make something happen with, like, if you were to use like a little Arduino board or something and have some smart coding in it. And so what I was looking at was like, is there a measurable resistance for when you stretch the wire? And if so, can that trigger some other kind of mechanical reaction? And the answer is yes. So it does change the resistance momentarily when you stretch it, even though it doesn't break the connectivity. And I haven't gone too far down that rabbit hole, but it is definitely something that somebody could explore.
And you've been talking about silicon, but are there other bases you have explored?
So I haven't gone too much into it because I was really focused on silicone because of how skin friendly it was. Basically, there's if there is somebody with a silicone allergy out there, it's extremely, extremely rare, and so it was super safe for body application. But honestly, I think you could look at anything else that is stretchy and potentially have it, embedded in it. For example, the wiring that I was working on to make stretchy is just like a regular rubber. It's not anything fancy.
Do they have stretchable wires? Should I go look on Amazon for stretchable?
Not that I've seen, not for like conductive wiring.
That's a difficult problem, I think.
Yeah, some people have gotten really clever by, like how you can weave wires together and they have like a stretch to them because of how they're woven. Some people have done some really cool stuff with that and created multi-wires based on that. But they're also kind of bulky, to be honest, because they're essentially a woven bracelet. But in my searching, I have not found much in the way of stretchable wires because metal doesn't tend to like to stretch.
Well, I mentioned kirigami earlier. That's the fancy way of saying cutting small designs in paper so that it flexes in different ways. Mm-hmm. And so if you take a flex circuit and you run your trace back and forth, let's go with the sine wave because people know what that looks like. And then you cut out so that the help me out here.
I'm not an origamicist.
You cut out the acetate
Okay.
flex circuit, not so that it follows the sine wave, although you can do that, but just putting in cuts where the sine wave is the furthest away from you. Can you picture that?
No.
No. Okay. So you have a sine wave.
Yeah.
And then as it goes up,
Yeah.
you cut below that. And as it goes down, you make a cut on the top. And as it goes up, you cut below it.
Okay.
So now you still have a sine wave that is full of metal, full of copper tape. But you also have the substrate it's on has 2 holes for every cycle of the sine wave.
Okay.
So I've seen something similar to that. I was at SuperCon a couple years ago, and you meet all sorts of interesting people. And I forget the company name that this gentleman worked for, but he had a stretchable wristband, basically, that was like a series of 6 wires, extremely flat. I would say it was like less than a millimeter thick. And when you looked at it closely, it was copper embedded into some kind of like rubber or something like that. And it was essentially, the lines were sine waves. So the traces were sine waves, very, very small ones going from one end to the other of running the length of essentially this wristband. And they were sine waves. And what that allowed for was the stretching of the material that it was in. So you're not wrong that that's kind of the way to go. I don't know where that company is at, but essentially one end of the bracelet had pads so you could connect to those traces that ran through the material. Yeah. It was really cool.
The advantage to doing that is that you do get a stretchable wire, but whereas cutting out a sine wave might give you some stretchableness, it won't pull it back. But with the kirigami slices, it will pull it back for the most part. Mm-hmm. And so it will go back to its original form. Yeah, I guess that's the way to phrase it. That's what I've been thinking about doing for like fabric mounted electronics. I see the conductive threads, and they have some stretch, but just not as much as I stretch my clothes, apparently. And so this having a flat thing that can stretch seems better to me. But now you've got me interested in gallium silicon tubes and then the ICs, the LEDs, the resistors, these aren't stretchable. So do you just use really small ones?
Yeah, just use really, really small ones. That is the key. Anything that's bigger, and then you have to bend it, you risk popping it off the board. So the smallest area you can have, the better, because then the flex of the surface doesn't really affect it.
But how do you solder things onto the gallium?
So that one you can't solder. When it's embedded in the gallium, it's really okay. So if we're talking just being on a flexible board, smaller is better. If you're talking about being in the gallium, bigger is actually a little bit better, because what happens is your gallium will try to leak from one end to the other. So it'll basically bridge your circuit and short circuit your entire thing, which was another reason why it wasn't super great for my application, because the really tiny lights just didn't create enough space. Because as we've learned, silicone doesn't like to stick to anything that involves LEDs as well. And so you can treat the back of your components where the where the leads aren't, like where the wires that connect to your gallium aren't, with a chemical. I forget what it is, but you can kind of coat the back of it, and it'll help the silicone stick to it, so it doesn't allow a channel to form between things. But when you have really small components, you are extremely prone to that happening, which is kind of why I went down a different pathway. I was like, the more these people like stretch things, they're going to wear it, they're going to pull it off, they're going to put it on. It is just going to break it over time. The wear on it is going to happen. And so when you're working with Gallistan and doing your silicone embedding, go a little bit bigger than you might want to, because it's going to allow you a better opportunity for it to not bridge the gap.
Have you tried wearing any of the silicone flex circuits? Are they hot?
They're not hot because the heat tends to come, like when the components are so small, if your components are hot, it's because you're short circuiting.
Right.
No, I just meant my own body heat doesn't escape then.
Oh, yeah. If they get too big, you can get kind of sweaty, and it can get really warm. That's another reason why I also kept the Sprite lights down to smaller sizes because the more silicone you have covering your body, I don't know if you've ever worn one of those adhesive bras, but you pull it off and you're like, ew, because it's like all sweaty and gross inside of it from walking around. So that's why you keep them small, so it's less likely to get too warm on you.
I'm pretty sure at least half of our listenership has never worn one of those silicone bras.
Well, they should give it a try. It's a hoot.
At least half.
It's a very natural look.
Let's see. I wanted to ask you real quick about the Bay Area Maker Faire. You went to that recently?
I did. Yeah, just a few weeks ago.
How was it?
Oh, it was fun. I believe this is the second year that it's on Mare Island, up in the Vallejo area. I went the first year also, and they were definitely still finding their way when I went the first year. I would say it like doubled in, number of things to see and do from the previous year. It had a full-on dark room. It had the more kind of like commercial manufacturing area where you could see like a lot of people don't have exposure to seeing like the really big 3D printers, and they had some of those on display printing stuff. And then it just had a huge, they always embody the maker spirit at these kind of events. And so there was a lot of that going on. People just demonstrating cool stuff that they've made. Some people were selling stuff, which I always support. Buying from small makers, support your community. And then it just had a lot of people walking around who had cool stuff that you could look at and talk to them about because they brought out their projects that they just wanted people to see. And it also, it had some of the, I don't know if other folks have been to maker fairs, but the cupcakes, were back and in force.
Oh, wow.
And the cupcakes are so great. If you don't know what the cupcakes are, they are, life size, or not life size is usually small, but I mean, huge cupcakes that are mobile. So they have little motors in them and people write in them, and then their head sticks out of the cupcake and they wear a little cupcake hat. And so they can see as they drive around. And so it's just like basically little vehicle cupcakes, like cruising around the Maker Faire. They are a delight every time you see them, and the cupcakes were there. So that was just a nice callback to the OG Maker Fairs, that used to happen.
The original Maker Faire, where was it?
Oh, San Mateo.
San Mateo. You've been in the Bay Area for a long time, and you've been a maker for a long time. Did you go to those when they started? So a lot of my maker years were actually down in Los Angeles. So I was in the Bay Area until very early adulthood, maybe my very early 20s. And then I went down to LA for around 15 to 20 years for my career. It took me other places. And so I would hit the one down in San Diego primarily, which was a tremendous maker fair. It was excellent. And what does a chief operating officer do? Whatever the company needs. It is one of those roles that is, like a Jill of many trades kind of role. For some people, it means overseeing HR, finance, and IT. For some people, it means, building operations. For some people, it means all systems and sysadmining. Sometimes it means, prying open elevator doors and figuring out how to get your people out of your trapped elevator because your building is from the 1930s and you have college kids who are interns in there, and well, you're going to get them out. So it could mean that seems like an odd example.
It's very relevant to my recent experiences. But it can mean just about anything a company needs to run operationally, to all the behind the scenes stuff that enable the people actually doing the work in the company to do that work without having roadblocks and barriers. And it leaves you time for making. Not traditionally, but I set very specific work-life boundaries. Katherine, are there any thoughts you'd like to leave us with? I think for all those listening out there who want to make things and do things and maybe don't have the traditional background of like an electronics degree or engineering degree of some kind, do it anyways. there are so many resources online and wonderful communities online, on Discord, on Hackster, on Hackaday, where people have written and put really interesting things that you can read about and learn. It doesn't matter if you don't know anything, because that's half of the fun is finding it out. So do the impossible, try to make the thing. The worst thing that happens is that your neighbors look at you funny while you're smelting metal in your driveway. It's not that big of a deal.
Our guest has been Katherine Connell. You can find her on Hackster and at Hackaday as The Small Wonder or Smalls in other online communities.
Thanks, Katherine.
Thank you so much.
Thank you to Christopher for producing and co-hosting. Thank you to Simon and Liana for their questions. They are in our Patreon listener Slack group. And finally, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now a quote to leave you with from Vicky the Robot.
Why?
We don't have skeletons in our closet. They're in the back of the condo.